Okay, so in the lecture on decisions, we laid some theoretical basis and ran through one example of hypothesis testing of the mean. Here we're going to continue with that and continue on the testing for equality, also known as the two-tailed test. And so in general, okay, the parts of any of these hypotheses tests, we're going to have the hypotheses, we're going to have the test criterion, and then we're going to have running through the test criterion to make our decision. Okay, for the two-tailed test, the hypothesis testing of the mean for equality, we have the first part of the test, the hypotheses. Okay, since we're testing for equality, its logical negation is inequality. Okay, our test criterion, okay, which tells you what to do. Okay, reject H0 if the absolute value of your test statistic is too big. If it's too many standard deviations away from the mean, the too many standard deviations being determined by your significance divided by 2, all right, on a table lookup. Okay, and then you get your data and you do your calculations and then make your decision. Okay. Okay, after years of teaching this, I've come to, this is just like filling out a form. Okay, after you've got your stuff set up, you just go along and you're putting things in blanks, filling out a form. The filling out is done in 2 steps. The first step is before you take data. You determine what your hypothetical mean is, and you determine your level of significance. Okay, and use that in setting up your test statistic. And after the data, taking the data, you fill in, okay, what's my n, what's my sigma, what's my x bar, you put that in your formula and you grind. Okay. So example 1, a famous researcher has determined that the southeast Kansas strip pit salamander's eyes are separated by an average of 5.2 centimeters. A local grad student is testing that result. That student can become famous in the circle of those who study such things if she can prove the famous researcher is wrong. Okay, the level of significance is set at 0.01. This is a very tight test. She only wants to be wrong 1% of the time. She's gambling with her career here. The grad student samples 57 salamanders and obtains a mean of 4.8 centimeters with a standard deviation of 0.5 centimeters. Okay, so what was he was saying it was 5.2, she's saying 4.8. Okay, these are different, but okay, they're going to be different. Is this different in a statistically meaningful way? Okay, so the solution, we assume he's correct. Okay, if you assume somebody is correct and then prove that he's not, then they have to believe you. Okay, alternative hypothesis, he's not, and we obtain, okay, we're using his number here, 5.2, and this is a table lookup, okay, at a 1% level of significance. So if our data, our average, is too far from his, okay, then he's wrong. And so we run this through and we get 6.04 and we say, okay, is 6.040, is it bigger than 2.5? And the answer, yeah, it is bigger. Okay, so we approve this, and we're not even worried about it. Okay, Johnny come lately, the new man in quality control, believes the filling machines in the coffee factory where he now works are misfilling. The cans of coffee are supposed to contain 788 grams of coffee, and company sets the significance level at 0.05%. If he samples 100 cans and obtains a mean of 7.870 grams with a standard deviation of 2 grams, what decision does he take? Okay, so you're filling coffee cans, and you want to get them at least full, but you don't want to get them too full. So you set a target, and you try to get as close to that target as you can, because you don't want to short sell your customers, but neither are you in the business of giving away coffee. All right. So the hypothesis is that the machines are filling hunky-dory, and if that's not true, we must assume that they're not. Probably shut down the machine and recalibrate it. Reject H naught if x minus 788 over the sigma over the square root of n, this test statistic, with the absolute value signs, right? So even if you take this and get a negative number, the absolute value sign is going to make it positive. Okay, if it's bigger than that, okay, well, we run the numbers on this, and we get 5, and yeah, 5 is greater than 1.960, and so we do reject. If it had been 1.2, nah, we're not worried about this.